there's no doubt coral reefs are beautiful. They are some of the oldest and most diverse ecosystems on the planet, but they are also irreplaceable, and that is the problem. I'm Dr. Joleah, and I study coral reefs, which are made up of tiny individual animals called polyps. Over many years, they build their skeletons upon one another like tiny apartment buildings, and they're so large they can be seen from space. Corals occupy just 1% of the ocean floor, but they're home to over 25% of all marine life, with over 2 million different species. At UCI, our research takes us to a place where over half of the world's coral reefs exist, and where 3 out of 4 people live within 30 miles of a coral reef. Globally, coral reefs are very important. They provide vital resources and services to people, including new pharmaceutical compounds for medical uses, income from tourism, coastal protection from waves and shoreline erosion, as well as food and cultural value. And this is why the health of these reefs have a huge impact on marine biodiversity, but also our livelihoods. But coral reefs are under a tremendous amount of pressure from climate change and mass bleaching events. And our recent research has shown that another significant threat is facing the world's coral reefs and the billions of people that they support: plastic waste. It is one of the most rapidly growing threats to our oceans, but the first step in addressing this threat is to quantify it. And up until last year, we knew how much plastic was entering our oceans. We were watching it wash up on our beaches. We were finding it floating on our surfaces, but we did not know how much plastic was underneath the water's surface. So with the support of collaborators from around the world, my research team and I surveyed 1 million corals while we were underwater on scuba. And we used these findings to publish the first and most comprehensive estimates of plastic waste on the sea floor. And from our calculations, we estimate that there are 11 billion pieces of plastic waste on coral reefs just in Asia Pacific alone. And what's more is that if we don't do anything about it, by 2025, it will increase 40%. That means that there will be 17 billion pieces of plastic items on our coral reefs. That is 2 items for every single person on Earth. And we're not just concerned about how ugly this will look. We're concerned about the health of these irreplaceable coral reefs, because our research has uncovered something even more alarming than the explosive growth of plastics in our oceans. We found that corals that are in contact with plastic are 20 times more susceptible to disease when they're in contact with it. 20 times. But why? Why do we not know this? Well, we believe that plastic trash acts as this perfect vessel of harmful marine bacteria because it has tiny little pits and pores that they can attach to easily. And when the plastic trash drifts around our ocean, it gets tangled up in our coral reefs, and it creates cuts and open wounds for disease-causing microbes to invade, kind of like a Trojan horse. Now here's just one example, polypropylene. Now it's a very common plastic that can be found in everything from our children's toys to your toothbrush and to bottles. And on land, it's perfectly harmless. But in the sea, it is often colonized by a bacteria called Vibrios, a pathogen that is linked to a globally devastating group of coral diseases. But here's the human impact. Vibrio also causes cholera. Millions of people contract cholera, and even 140,000 people will die from it every single year. So at UCI, we're not just trying to quantify the problem of plastic waste on our coral reefs, we're trying to find novel solutions. We have discovered that some of reefs even show fewer signs of disease and plastic, and that they're thriving and healthy. But once again, why are we seeing this? What is different? Our research is urgently focused on trying to find the answer. So here's the big clue. This seagrass that I'm standing on is thriving in these shallow waters. And we believe that seagrass plays a crucial role in protecting reefs from plastic and from disease. Seagrasses are one of the largest coastal ecosystems on our planet, and they are found on every single continental shelf except for Antarctica. These are the rainforests of the marine environment. They can capture atmospheric carbon 35 times faster than a tree. But seagrasses also protect our coastlines from waves and flowing water by trapping sediment. But what we've discovered is that seagrasses are also trapping our plastic, acting as this first line of defense and a natural filter in the marine environment. And I believe seagrasses are doing a lot more. Our new research is revealing that seagrass blades have novel antimicrobial properties that can reduce marine and human pathogens in the water column by 50%. So in other words, seagrasses are trapping this plastic, but they are also disinfecting it. So how can we harness this natural process to protect our coral reefs and the living creatures that rely on them, including people? And that's the big question, and it will take a significant amount of work to address. And we already know that the answer to this very important question can be found in the world-changing research that is going on here at UCI. And that's why this university has such a brilliant future. Thank you.